Now in our last video dealing with expressions, we're going to look at factorizing. And really, factorizing is just the opposite of expanding. Students often find factorizing one of the more difficult things when it comes to expressions. And that's because essentially what you're having to do is to work backwards through the question to find out what it would have looked like before you would have expanded it out. Really, at the end of the day, the most important thing with factorizing, though, is that you have to understand what highest common factor means, and you have to be able to find the highest common factor between a set of terms. So that might mean 2 terms, that might mean, like this question, 3 terms. So you got to be able to find the highest common factor. Now, we practiced that in Unit 1, but we did that really only just with numbers. When it comes to algebra, we have to do that for numbers and for variables to certain exponents. So when we're talking about the highest common factor here, let's write it down in red. Let's write what our highest common factor is between these 2 terms. So the first thing we need to do is, what's the highest common factor between these 2 coefficients, or the 2 numbers that are actually involved? Well, as you can tell, they're both even numbers, and the highest number that goes into both of those should be 2. So I know that the highest common factor as far as the number is concerned should be 2 between 4 and 6. But I also must look at my variable, and I have to say, is there a variable that goes into both of these terms? And what's the highest exponent of that variable that goes into these terms? Well, here I've got an m squared, and I've got an m. So I definitely know that at least an m should go into both of those. And what I do is then I ask myself, okay, does an m squared go into both of those? Does an m cubed go in? M to the 4th? Well, when I look, does m squared go into both? Yes, it goes into this term, but an m squared would not go evenly into this term. I would not be able to divide this by m squared and get something as a nice even number. So I end up with 2m as my highest common factor, which means when I go to factorize this, the thing that should be on the outside, the term that should be on the outside should be 2m. And what I do is I set up a set of brackets, and I find out if I took 2m out of both of these sets of terms, what would end up in the brackets. Essentially, you're filling in a puzzle in a backward sense to expanding. So if I took 4m squared and divided it by 2m, what would I actually end up with? Essentially, what we're saying is, if I took 2m and expanded it out, remember when we were putting our arrows in with our other video? If I took 2m and multiplied it by something inside here, how could that give me 4m squared? Well, I know that 2 times 2 would give me 4, so it must be a 2. And I know that m times m would give me m squared. So my first term would actually be 2m. Then I get 2m times 2m, and I should end up with 4m squared. Negative 6m, what would give me 2m times something to give me negative 6? Well, the only way I can get a negative is, since this is positive, this next term has to be a negative. So I'm going to go 2 times negative 3 to give me 6. And m times something has to give me m. Well, I'm already going to get an m when I times this by negative 3, so I don't add any m here. Because if I add an m, I'm actually going to end up with m times m, and that would be m squared, but that's not what I have here. So I just need to multiply this by 2m times negative 3. So at the end of the day, there's my answer there. I've factorized that out so that when I am finished, it looks like the beginning of an expanding question. Now, if you want to, you can always go back by doing a check on what you've got. If I go 2m times 2m, I should end up with 4m squared. 2m times negative 3 should be negative 6m. This should look exactly like what you started with. And if it does, then you've done the factorizing right. So that's the basics for factorizing. Let's look at a question that looks like it's much more difficult because it's got many more terms, it's got many more variables and exponents involved. So the first thing we're going to do is we're going to take a look at it, and we're going to try and find our highest common factor. In this case, my biggest numbers along the way, I've got 16, I've got 24, and I've got 8. So my largest number between all 3 terms would be 8. Let's write it in red. 8. Now, if you wanted to, you could actually take out negative 8 if you wanted to, and then you'd be factorizing negative 8 out of each of them. I'm just going to factorize out 8 for this particular question. So I've got 8 coming out. So now I have to find out, as far as variables, Is there at least an a term in each one? The answer to that is yes, there's at least an a. Now, is there at least an a squared in each one? Well, there's a cubed here, a squared there, a to the fifth. Yes, there's at least an a squared. Is there at least an a cubed? Yes, there's an a cubed. Here there is not. So the largest variable to the highest exponent would be a squared. I look at my b terms. Well, I definitely have a b, at least one b term in each. And in fact, this one here is my largest inside of here as far as to the exponent. So I can't be putting b squared or b cubed because I wouldn't be able to divide that evenly. Right? So my highest common factor here is going to be 8a squared b. That means on the outside of my brackets should be 8a squared b. I set up my brackets. Now inside of that I should have three separate terms. 8 times what is going to give me negative 16? Well, that's negative 2. A squared times what is going to give me a cubed? That's going to be a. And b times what? Well, I've already got it. It's times 1, so I've already got the negative 2 there. Notice if I multiply this by this, I should end up with this. Going to the next one, 8 times positive 3 should give me 24. A squared times, I've already got it, the a squared will end up there. And b times, I need b here to get b squared. My last one here, don't forget I've got 8 times something has got to give me negative 8, so my answer here should be negative 1. A squared times something is going to give me a to the fifth, which is a cubed. And b times something's got to give me b to the fourth, which is b cubed. Now let's just go back and double check this with a check at the end to see if we're on the right track. 8 times negative 2 is negative 16. A squared times a is a cubed. B times, well, that term is going to be a b. Is that what I got in my first one? Correct. 8 times 3 is 24. A squared, there's no a term there. B times b is going to be b squared. Notice that's the same as that term there. And my last one should be 8a squared, negative 8. A squared times a cubed is a to the fifth. And b times b cubed should be b to the fourth. So there's a very long one here. And notice that ends up being the same as this one here. So that means my answer must be correct. If you go slow with factorizing, you should be able to handle it as long as you're being clear of your directed numbers and that you're making sure that you're actually starting with the highest common factor. A tendency sometimes with students is to just look at the numbers and jump into it and go, okay, my highest common factor is 2 or that it's 4, but really the largest number that's going to go into all of those is going to be 8. And don't just assume that just because all of them have an a, that my highest common factor is only a, because a squared also goes into all of these terms as well. So that's factorizing, and really at the end of the day, it's the opposite of expanding, so you can always go back and double check if you're comfortable with expanding out these kinds of expressions.